Hello all and welcome to Chapter 5. We're going to take what will feel like a slight diversion from calculus, from derivatives and things like that, and we will spend time tying the two back together. But what we're going to start with in Chapter 5 is estimating the area underneath the curve of a function. So the best way that, not the best way necessarily, the easiest way to estimate it is to use rectangles that are going to give us either an underestimate or an overestimate of the area beneath the curve. So if we take our attention to this drawing here, if you want to pause the video, get yourself set up for notes, make a small copy of this drawing, I encourage you to do that. Otherwise, you can, of course, print out a copy of the guided notes from Google Classroom. So if I'm looking at a function here, f of x, this is a green function, and I was asked, okay, what is the area beneath that curve? The area beneath f of x is approximately equal to the sum of the area of the rectangles that we see here. And remember, area of the rectangles is base times height, which in this case, the base of the rectangle is the difference in x. So we can write that as delta x, as the difference in x of the base. And then the height of each rectangle here is from the 0 to the value of the function. So for example, if I'm looking at the height of this rectangle right here, the height is determined by this point on the function. And you can either have an underestimate, which we see in red, or you can have an overestimate. And you'll learn eventually to predict if things are underestimates or overestimates. But the easiest way right now to predict that is to actually draw the picture. So we're going to look at some problems here, 1, 2, and 3, about estimating the area under the curve y equals x squared. And the best place to start with is just draw the pictures, and it'll be very easy to tell if something is an underestimate or an overestimate. So all of these problems are going to ask you to estimate the area under the curve, y equals x squared, on the interval from 0 to 1, using 4 rectangles and left endpoints. So if we look at our picture here, the endpoints, whether you're using left or right, will give you different answers. So if I'm looking at this point here, this is on the left of this rectangle, and that's what it means to be a left endpoint, versus, as you can see, we'll have other ones. But let's start with the left endpoint and the interval from 0 to 1 using 4 rectangles. So the first thing I'm going to do is I'm going to divide that interval, in this case from 0 to 1, into 4 what are called subintervals, and that's just going to be the bottoms of our rectangles. So in this case, do it as best you can. We've got 1/2, 1/4, 3/4. And these are our 4 rectangle bases. And then the height of each one is determined, as I said, by the value on the function. So here are the points that we'll be using. And now, since we're using the left, I'm going to draw the endpoints out from the left side until it connects back on the other. So now you have 3 very apparent rectangles, and this is just a rectangle that has a height of 0. And you can see, and if I shaded these in, if we add up the area here, this is going to be an underestimate for the area under the curve, because we are not including this little bit in our estimate. So the actual area would be green plus pink, but we're only going to find the green. It's going to be an underestimate. So the way I'm going to write this out is it's the sum of the rectangles. So the first rectangle has a base of 1/4. In this case, they all have a base of 1/4 because we divided 0 to 1 into 4 rectangles. So the first one has a height of 1/4. The next one has a base. And then this height here on the term, remember this is using the term x squared, so this is 1/4. And the x-axis, the y value, would be 1/4 squared. So that is 1/16. That's the height. The next one, base, is still 1/4. Its height is 1/2 squared, so that's 1/4. The final base, 1/4, times 3/4 squared, so that's 9/16. So then we can say that the underestimate of the area is 0 plus 1/64 plus 1/16 plus 9/64, which means that we are looking at an area approximately 14/64 or 7/32. Now you can turn that into a decimal, but this is pretty straightforward fraction addition. Since we have mostly common denominators, I had to just multiply this one by 1/4 on each side. Now, here's one estimate with left endpoints. For number 2, you'll notice a very similar strategy here, but in this case, we're looking at right endpoints. So we're going to start off the same by dividing, in this case, once again, 0 to 1 with 4 rectangles. Divide it by 4. And draw the heights up to the curve, in this case, still x squared. And now we're using the right endpoint, so this is the height of this first rectangle. This becomes the height, because these points are on the right side. There you go, and here. And what you can see here is that we are dealing with an overestimate because we have the area under the curve plus this additional area. So then if we were asked, oh, what is estimate the area, we could use, oh, what's a number in between my answer and number 1 and number 2. So similarly, they all have the same base, which is 1/4. And you can actually factor this out if it just makes the algebra a little bit easier for you. So 1/4. And then the height of this first rectangle here, the height at this point is 1/4 squared. So that's 1/16. The height of the next point is 1/2 squared. The height of the third rectangle is 3/4 squared. And the height of the last rectangle is 1. So you'll notice that a lot of these rectangles are the same. They're just scooted over. So like this rectangle has the same area as this rectangle. This rectangle here is the same area as this rectangle here. So you end up with your 16th, your 4th, your 9/16. It's just, do you start on the left side or the right side? So you're only ending up with one term different when you use left endpoints versus right endpoints. Since the bases are all the same, I'll keep the 1/4 here, and then this becomes 30/16. So the area here is approximately equal to 30/64, which we could express as 15/32. And if I wanted to find the exact area, I would now know, oh, well, I have to pick something in between 7/32 and 15/32. Maybe you say 10, maybe you say 12. You'll learn in this unit how to get that exact answer. But here we just want to look at the picture and ask ourselves, underestimate or overestimate. Now, the way you might ask yourself, okay, well, we could be more accurate is if we were using, instead of endpoints, we want to use midpoints of the rectangles, which absolutely is another option. It's just a little bit harder. So when we're trying to find rough estimates, we tend not to use them. What we'll do is the same thing. divide up our interval, in this case 0 to 1, into 4 rectangles. And in this case, though, the height of the rectangle is determined by the midpoint. So in each of those, you're going to want to take the midpoint. So in this case, we're looking at these points here of each. So this is 1/8, 3/8, 5/8, and 7/8. And when we draw our rectangles out, we're going to use those midpoints as the height. So this one, you can see we're now cutting the difference between our overestimates and our underestimates. And each of these, once again, has a base of 1/4. Because the base is still here, so in the case I illustrated, 3/4 to 1. So the base is all that. The heights of each are determined by these midpoints. So 1/8 squared, which is 1/64, plus 3/8 squared, 9/64, plus 25/64 for the third rectangle, and lastly 49/64 for the last rectangle. So the area then is approximately equal to 1/4. The nice thing about this is that they are all going to have the same denominator right away. So 84 over 64. And that tells us if we can simplify at this point, before we even multiply, 4 and 84 we can simplify as 21. And so the area is approximately equal to 21 over 64. Which, if we wanted to compare it to these ones, we had 14 over 64 as a lower estimate, 30 over 64 is an upper, so this makes sense that the midpoint, 21 over 64, is in between those two. And we will eventually learn how to tell if that is an overestimate or an underestimate. For right now, practice finding the area with these rectangles. And of course, let me know if you're stuck on anything. Leave me something in the comments, shoot me an email, or set up a Zoom meeting.